Hey St. Mary Grade 8s, Mr. McHenry back with another math lesson. Hope everybody's doing well and staying healthy and safe, and their families as well. Today we're going to be focusing on a new unit. We're going to be focusing on solving equation with algebra tiles. And I just want to start by saying that I know in the practice questions that they will seem fairly simple, the questions. And I know that many of you would be able to solve these questions by using guess and check or other strategies. But what I would ask you to do is that if you can look to solve them in an algebraic way like we are today, you will benefit from that because you will have that background knowledge as we move into later in the week in solving equations algebraically, but you will also have that background knowledge as you move into math for high school. So again, I know some of the practice questions are going to look fairly simple and you're going to be, well, I can find out what x is to solve for the unknown just by looking at it and doing mental math in my head. But I need you to go through the steps so you understand what you need to be doing so that when you go on to questions that are not as simple, you'll be successful. Okay, so we're going to do solving equation with algebra tiles. So you will recall that we used unit tiles to model integers where a plus tile was equal to +1 and a negative tile was equal to -1, and then we had our friend, put those together, we get our friend the zero pair. Okay, we're going to be talking about variables. And variables are a letter or a symbol representing a quantity that can vary or change. And we often use the italicized letter X. Okay, so an italicized letter X looks a little bit different from a normal X, okay, to represent a variable or unknown value we are solving for. This italicized X does not mean multiply, right? So when it looks like a funny X like this, italicized, that means that you're solving for the unknown, you're solving for that. This normal X means multiply. All right, and you'll see that in the questions that we are going to be doing. We can use variable tiles to represent variables where a positive x variable tile is equal to a positive x or positive 1x. Remember this positive x, it's assumed that there's a 1 in here, so a positive 1x. And else we have a negative x variable tile where that equals negative x or negative 1x. Again, we don't put the 1 in sometimes, so it's assumed that there's a 1 in there if there's no number. And again, if we put these two variable tiles together, positive x and negative x, we get a zero pair. Okay, you'll recall when we solved equations earlier in the school year, an equation is a statement that two algebraic expressions are equal or balanced. And I hope you can remember the balance that we had where if we change, it was balanced and then we changed something, it was unbalanced, and then to get it back into balance, we had to do the same thing to the other side. Okay, so we have an algebraic equation here, 2x is equal to 6 minus x. These are both algebraic equations and they are equal. They're balanced right now. Okay, and remember that to keep the balance of an equation, whatever you do to one side of the equation, you must also do to the other side of the equation. You're going to make that, got to have that in your head, okay, when we're looking to solve algebraic expressions. Okay. For the algebraic equation, 2x is equal to 6 minus x. All right, the first thing that we want to do is interpret the equation in words. So what does this mean in words? Well, this means 2 times, okay, and remember there's a little itty bitty multiplication inside there. So 2 times a number is equal to 6 minus the number. Okay, and there's one other piece that we need to say in here, is that we're going to say let x represent the number. Okay, so in words, this 2 times a number, because we're letting x represent the number, is equal to 6 minus the number. So that's interpreting that in words. The next thing that we are going to do is we are going to use algebra tiles to solve the equation. So I start off again here with 2x is equal to 6 minus x. And when we solve using algebra tiles, we have a left side, which I'm going to put as ls, and is equal to the right side, which I'm going to put as rs. And then what we would do is we would draw the tiles. And we put a little squiggly down the middle there, and we draw the tiles so we have 2 variable tiles. So 2 positive x variable tiles on the left side. And on the right side we have 6 positive tiles and 1 negative x variable tile. And you can see that I'm differentiating these by the variable tiles are rectangles, and obviously they have positive x or negative x in them, and the unit tiles are the circles. Okay, so how do we go about solving this? Well, what we need to do first is we need to isolate the x tiles on one side of the equation by getting all the x tiles to one side and getting all the unit tiles to the other side. And then we'll be able to solve for one x tile, or solving for x. Okay, so we're looking to get all the x tiles to one side. To isolate the x tiles. And so a hint here, and I'm going to say this a couple times, is that you usually want to isolate the x tiles on the side that has the most positive x tiles. So if I look at this here, where are the more positive x tiles? Where there's more positive x tiles on the left side. So I'm going to look to isolate the x tiles on the left side here, and so that being the, okay, and so I'm going to go forward with that. So how do I isolate the x tiles on the left side? Well, I also have to just have number tiles on the right side, and right now I have a negative x tile on the right side. So how do I get rid of that negative x tile? Well, I can get rid of it by adding a positive x tile to this. So I'm just rewriting this here. And I'm going to add a positive x tile there. Well, what's my rule? And I'm just going to put what we had first. Whatever you do to one side, you must do to the other. What did I do to this side? Because it's unbalanced right now. I need to balance it out by doing it to the other side. I need to add a positive x tile on this side. Okay, now I can look and say, do I have any 0 pairs anywhere? Well, yes, I do. There's a 0 pair right here. Okay, and now I am going to simplify again. So on this side I have 3 positive x tiles, and on this side I have 6 positive unit tiles. Okay, so I've got all the x tiles isolated on the left side. I've got only unit or number tiles on the other side, so I'm good to go. So now I know that 3 x tiles is equal to 6 positive unit tiles. But we don't want to know what 3 x tiles is equal to. We only want to know what 1 x tile is equal to. So can we rearrange these unit tiles equally with the 3 x tiles to find out what 1 x tile is equal to? And the answer is yes, we can. If we rearrange them equally, we see that two unit tiles match up with each x tile. So now we can say that x is equal to 2. All right. So we got x equal to 2, but we want to verify or check our work. And this is a part where many students in the past have not paid attention to, and I can guarantee you that in grade 9 math, you're going to be asked to do this. So again, this is something to do well now so that you have this in your background knowledge. We want to verify or check our solution. And how do we go about this? Well, we go about it by writing out the equation again. We write out 2x is equal to 6 minus x, and we're going to say where x is equal to 2. And again, I have a left side and I have a right side. Okay, and they're equal. I put a little squiggly down the middle, and I'm going to solve for them individually. And by substituting in x is equal to 2. And if I get the same solution on the left side and the right side, then I know that x is equal to 2 is correct. So on the left side, I have 2x. And on the right side, I have 6 minus x. And what I'm going to do is I'm going to solve the left side first. So I have 2x here. Well, what is x equals? Do I think x is equal to? I think x is equal to 2. So I substitute in 2. Now I have 2 times 2. Remember, these brackets mean times. 2 times 2 is 4. Now I'm going to work on the right side. And you can see I put equal sign. So I put an equal sign here. 6 minus x. What is x equal to? No, I think x is equal to. I think x is equal to 2. So I substitute in 2 for x. And I solve, and I get 4. Then I can write, therefore, left side equals right side. Therefore, and remember these 3 little dots mean therefore, x is equal to 2. Okay, that was our first example. We're going to go through a few more here because there's a few wrinkles that we want you to be aware of. The next one that we're working on is 3x minus 8 is equal to negative x. The first thing that we want to do is interpret this equation in words. What does this mean? Well, that means 3 times a number. Okay, so remember that there's an itty bitty multiplication sign in there because this is an italicized x. 3 times a number minus 8 is equal to minus the number. And again, we need to put in here, let x, that italicized x, represent the number. Okay, so we've got that down in words, what that means. Now we're going to solve the equation. So I'm going to write it out again here. And I'm going to put my left side is equal to my right side. And I'm going to put my tiles down. So on the left side, I have 3 positive variable tiles. And I have 8 negative unit tiles. And on the right side, I have 1 negative variable tile. Okay, what do I want to do? Well, I want to isolate the x tiles on one side and the unit tiles on the other side. And remember that hint, I want to isolate, it's usually good to isolate the x tiles on the side that has the most positive x tiles. In this equation, where are the most positive x tiles? Well, they're on the left side again. So I'm going to isolate or get only x tiles on the left side, and I'm only going to try to get only unit tiles or number tiles on the right side. So how do I go about that? Well, I want to only have x tiles on the left side. So how do I get rid of these 8 negative unit tiles? Well, I can use our friend the zero pair, and I'm going to add 8 positive unit tiles to the left side. But my equation is now unbalanced. I need to balance it out. Whatever I do to one side, I must do to the other side. So what do I need to do to the right side? I must add 8 positive unit tiles. Okay, now I'm going to simplify, and I simplify by saying, look at all these zero pairs. So they cross out. And what am I now left with? Okay, I have 3 positive x tiles on the left side. And I have 1 negative x tile on the right side and 8 positive unit tiles on the right side. So I'm still trying to get my goal of getting all the x's to one side. And all the unit tiles to the other side. So I only want unit tiles on this side. So I got to get rid of this negative x. How can I get rid of that negative x? Well, I can add a positive x to the right side. So I'm going to add a positive x to this side here. But whatever I do to one side, I must also do to the other. So I need to add a positive x to the left side as well. And I look for any zero pairs. Well, here is a zero pair. The variables cancel out. And now I'm going to simplify again, so that on the left side, I now have, and is equal to the right side. On the left side, I have 4 positive x tiles. And on the right side, I have 8 positive tiles. Okay, so now I know, what do I know? Well, I know that 4x is equal to 8. I don't want to know what 4x is equal to. I only want to know what 1x is equal to. So is there a way that I can rearrange the 8 positive tiles so that I can find out what 1x is. And yes, there is a way I can do that. I can rearrange so that they're equally shared with the x's here, and every x gets 2 positive tiles. So therefore, x is equal to 2. And again, I need to check or verify that x is equal to 2. So I'm going to do my verify or check. And again, what am I checking? Well, I'm checking the equation 3x minus 8 is equal to negative x. Make sure we get that negative in there, that's important. Negative x, where x is equal to 2. And again, I have a left side and I have a right side. I put a little squiggly down the middle where the equal sign is. I write out the expressions. 3x minus 8 is equal to, and on the right side, negative x. And I work on one side at a time. I'm going to work on the left side first. So I have 3x minus 8. I substitute 2 in for x. I use my BEDMAS rules. Remember, this is multiplication here. I get 3 times 2 is 6 minus 8 is equal to negative 2. On the right side, I have negative x. I substitute in for x, and I get negative 2. Therefore, left side equals right side. Therefore, x is equal to 2. Now, what happens if I didn't get left side equals right side? Well, that would mean that I need to go back and check my work in the equation. Because if left side does not equal right side in the verify or check, then something we need to go back and correct something. Okay, and that's why it's important to be able to do the verify or check. Okay, our last example. 2x plus 3 is equal to 4x minus 3. Again, interpret this equation in words. This means 2 times, right? This is the italicized x, but there's an itty bitty multiplication sign in there. 2 times a number plus 3 is equal to 4 times a number minus 3. And again, we need to write let x represent the number. All right, so now we're going to solve for this. So we're going to rewrite this again. 2x plus 3 is equal to 4x minus 3. And we're going to put our left side is equal to our right side and put a squiggly down where the equal sign is. And we're going to write on here 2 positive x variable tiles and 3 positives. And on this side, we're going to have 4x positive tiles and we're going to have 3 negative tiles. Okay, I need to figure out where I'm going to isolate for x's. Get all the x's to one side, get all the unit tiles to the other side. Well, I look at this, and again, that hint is that we want to isolate the x tiles on the side that has the most positive x tiles. So where are the most positive x tiles? Well, they're on the right side. So we're going to isolate for x on the right side this time, and that's okay. You can isolate for x on the right side or the left side. Okay, so how do we go about doing that? Well, the first thing that we're going to do is we're going to say if I only want x tiles on the right side, I don't want any x tiles on the left side. So I need to get rid of these two positive x tiles on the left side. And how do I do that? Well, I add 2 negative x tiles. But again, it's because I've added something to the left side and not added something to the right, it's unbalanced. How do I get it back into balance? Whatever I do to one side, I have to do to the other. So I'm also going to add 2 negative x variable tiles to the right side. And now that I've done that, I'm going to look for any zero pairs. Yes, there are some. There's 2 on the left side here, zero pairs, cancel out. And there's 2 on the right side with the variable tiles. Okay, and I'm just going to simplify again. So on the left side, I have 3 positive tiles, and on the right side, I have 2 positive x tiles and 3 negative tiles. Okay, I just want x tiles on the right side. And I have these 3 negative tiles here, so I got to get rid of them. How do I get rid of them? Well, I make some zero pairs. How do I make zero pairs? Well, I'm going to add 3 positive tiles. And again, out of balance. How do I get back in balance? Whatever I do to one side, I have to do to the other, so I got to add 3 positive tiles to this side. Now I'm going to look for zero pairs. Any zero pairs? Yes. Cancel these out. Okay, and I'm going to simplify again. So on the left side, I have 6 positive tiles. And on the right side, I have 2 positive x tiles. Well, now I got only x tiles on the right side and unit tiles on the left side, so I'm good to go. But I don't want to know what 2x is equal to. 2x I know is equal to 6 now. I only want to know what 1x is equal to. So can I arrange the tiles so that they are such that we can find out what 1x tile is equal to? And yes, I can, and they're already arranged in that so that we can see that 1x is equal to 3. And it can be written like this: 3 is equal to x, or if you don't like it that way, you can flip it around. X is equal to 3. And again, the last part of this, I need to verify or check my solution. Okay, I'm going to say, remember that it is 2x plus 3 is equal to 4x minus 3, where x is equal to 3. And I'm going to have my left side here, squiggly down the middle, right side here, and I write out equals 2x plus 3 equals 4x minus 3. And I am going to now just solve for the left side. So solving for the left side, I substitute in for x. What is x equal to? It's equal to 3, so it's 2 times 3 plus 3. Again, using my BEDMAS rules, I want to do the multiplication first, which is 2 times 3 is 6, plus 3, which is equal to 9. On the Right side, I have 4x minus 3. I substitute in for x. 4 times 3 minus 3 is equal to, I do the multiplication first. 12 minus 3 is equal to 9. Therefore, the left side is equal to the right side. Therefore, x is equal to 3. Okay, so a lot of examples there, and I know some of you can go about doing this and looking at the equation and doing some mental math in your head and saying, well, I know what x is equal to, and then just giving that x is equal to 3. Okay, you're doing yourself a disservice if you do not go through these steps and understand how we go about solving equations. These are simple questions because we need to start with simple questions to be comfortable and have success. If you don't go through these steps and understand the steps, you're going to have some challenges when we get to solving it with bigger numbers and more complex questions, and again, having that background, not having that background knowledge when you get to high school. So the practice questions with the answers will be posted on the D2L site. Stay safe, everybody.